In the last part, we built the basic hull structure with some plywood and made it smooth using homemade sparkle. If you haven't yet seen that video, you can click on the I button or you can watch it from the link in the description below. I started prepping the hull for laying fiberglass and resin on it. For this I am using polyester resin as it's cheap and works great with fiberglass. I bought it from Carbon Black Composites and it came with MEKP catalyst, cobalt accelerator and some droppers. I bought some generic fiberglass woven cloth. Woven fabrics are strong reinforcements because fibers are bundled into yarns oriented in perpendicular directions. Ratios and proportions for mixing resin and catalyst may vary from manufacturer to manufacturer, hence properly refer to the instructions provided by the manufacturer. Do not forget to use gloves and safety goggles while working with composites. It is important to first coat the structure with resin. This ensures that all the air trapped in the pores of wood gets removed. If this step is not properly executed, then in the later stages of fiberglass and curing of resin, air in the pores will rise to the surface and will get trapped beneath the fiberglass coat, and this in turn will form air bubble. While applying resin on the fiberglass fabric, observe the transparency of the fabric. It will become completely transparent once it soaks enough resin. If your structure have tight curves, go for lighter or less dense fabric as it is easier to bend across curves. You can also use chopped strand mats of fiberglass on such curves. For the curing process to go smoothly, you should keep it in a dry place, away from humidity, away from moisture. For me, the curing process didn't go as well because the place where I live is always moist and humid. Therefore, it took a lot of time for the resin to cure and also in the end it was tacky. Here are the air bubbles I was talking about. I used some sketchy hack of the internet to remove these air bubbles, but it kind of worked, so yeah. I filled some resin in a syringe. I used the syringe to inject resin in the bubble. If you are going to do this, make an extra hole for air to exit easily. Once you have injected resin, you will again see the transparent fiberglass coat. You can use some tape to seal the hole through which you have injected resin. I forgot to do it, hence during the curing process, resin by the action of gravity dripped out of the bubble, letting in some air and again formed small air bubbles. After everything was cured, I cut off excess composite and moved on to the sanding process. I used 80 grit sandpaper first and then used some 200 grit to smooth things off. You can see those air bubbles causing the fiberglass to rip off. Look at these massive defects formed at the curves. To fix these, I used the saw to rip off the voids and simply used epoxy resin to cover for it. And yeah, it worked. Then I applied a white coat of enamel paint inside the board to give it some resistance to moisture. For making shaft tubes, I first dismantled some scrap brushed motors and salvaged metal bushings from them. These were of perfect dimensions as per my requirement. For shaft tubes, I used this old antenna tube from my radio. And lastly, for lubrication and water seal, I heated Vaseline, which is basically petroleum jelly. I used a syringe to inject petroleum jelly in the shaft tube. Also, I used some resin to fix the bushes on ends of the shaft tubes. Sorry, I forgot to record that part. Now, my shaft was 2 mm in diameter and I needed it to be 3.17 mm to fit it into the shaft coupler. So I cut off a part of a refill and press fitted it onto the shaft to make it thicker. But it turned out to be a disaster. I'll explain the why part later. For making shaft couplers, I used an axle from bicycle and washed and cut it to size. I took it to a lathe shop and got the center and the top 2 holes drilled. I then used a taper tool to create threads in the holes. I did some adjustment to 2 normal screws to use them to hold shafts in place. I then fixed 2 brushless motors on a piece of plywood, used a file to create a flat surface for the screws to sit on the shaft. I took utmost care that I do not remove too much material from the shaft or it will imbalance the shaft weight. If you like my work, leave a like and subscribe to my channel. It would mean a lot. I used some epoxy resin to fix all the parts in place. Once it was cured, I started working towards the rudder assembly. I sanded off the edges of the rudder to make it more aerodynamic. I also coated rudder parts with fiberglass and resin. I used this metal geared servo which had sufficient torque to rotate rudder. Here I am making hatches and hatch covers so that water, even if it spills on the board, do not enter inside and fry my electronics. I referred to this excellent video by Sailtails for making hatch covers. I don't think that I can explain the process better than him. Hence, I will put down the link to that video in the description below. I then coated the ship deck and hatch covers with fiberglass. Then it was time for the paint job. I used enamel paint. I didn't have access to primer and hence it didn't stick too well. so I had to do multiple coats. I haven't added the GPS and flight controller yet. I wanted to first test how it works on remote control. The wiring was fairly simple. The two BLDC motors connect to the ESC. These ESC get signal from receiver and the rudder was also directly connected to the receiver. And now it was time to take it out and test it. It sails like magic. But right off the start, I noticed a few issues. Also, there were some catastrophic failures after a few runs. I am going to fix all these things and add GPS and flight controller in the next part. So stay tuned, subscribe and like the video. If you have any doubts or suggestions, you can comment below or text me on my Instagram.